And we are now moving to IT security at the highest level. Please welcome David Mohren, DevOps specialist at CLYSO. His presentation, Ceph-CSI support for AES-GCM, addresses the crucial question, is your encryption truly secure? In an era where DORA and German BSI sets strict standards, simple confidentially is no longer enough. David will introduce us to the need of cryptographic integrity and unveil the strategy of integration the AES-GCM authenticated encryption cipher directly into Ceph-CSI. Please welcome David Mohren of CLYSO.
Yeah, thanks for the nice introduction. So I'm 25, so you know I'm legal age at the very least. Okay. So welcome to my presentation. Ceph-CSI support for AES-GCM, challenges and opportunities. And yeah, what can you expect from this talk? So the idea why I wanted to do this talk is I had some ideas on how to get, on how to make data at rest more secure in Ceph-CSI. Okay, and you might be from a fraction that doesn't use Ceph-CSI at all, or Ceph-Rook for that matter. But the concepts I'm going to explain, they are also applicable to other parts in Ceph. Yeah, so here are beginner's welcome. So I will give an intro into some cryptographic basics. So if you don't know what you're using right now for encryption, I'll also go into it a little bit and some of the problems that come with it. And I also give you guys an introduction to Ceph-CSI. Obviously like a high level one, but you'll know what I'm talking about, hopefully. Okay, and throughout this, like a very important thing I want to mention, so people won't get confused. So in the talk, I will talk about integrity a lot. But here I'm referring to cryptographic integrity, and I want you to keep that in mind, okay? Because there's a difference against protecting against errors. Like a CSE checksum, that's for error correction. But here I want to implement or like integrate something that's protects against malicious modifications. Okay, and then, yeah. So, yeah, I'll give you some motivation first, some context, then some cryptographic challenges and some of the solutions that are available also throughout the Linux community. Then I'm going to talk a little bit about the PR I opened, how I wanted to integrate my proposed solution into Ceph-CSI, and at the end I give you a small outlook. Okay, so let's start at the very beginning. So what do we even want to achieve in information security? So there's a very basic model is called the CIA triad. So first of all, we want to achieve confidentiality. So that essentially means only authorized may understand what information is about, right? Like if you don't have a key and a cipher, like some information, you don't understand it without the key. Second of all, we want to achieve some sort of cryptographic integrity. Not everyone may be allowed to change ciphertext or information, and if someone changes the information, we would like to know about it at some point. And lastly, obviously, availability. Information has to be accessible in some timely manner, right? Okay, so what is even this AES-GCM that I have in the title? It's a cipher that establishes confidentiality. So we encrypt data, if I don't have the key, I can't understand it. But at the same time, it also establishes cryptographic data integrity. So if someone were to flip a bit in an existing ciphertext, and on the decryption process, that will be noticed. It will essentially throw an error and say, oh yeah, someone has modified the ciphertext. And this is pretty cool, because typically ciphers only really establish confidentiality. And they sometimes implement means to establish cryptographic integrity by heuristics. So they kind of help there, but there's not really a deterministic behavior. And these types of ciphers are called AEAD ciphers, Authenticated Encryption with Associated Data. You may know this from TLS 1.3, where they are mandatory nowadays. Yeah, but there are obviously other ways of establishing cryptographic confidentiality and integrity. Now for the big question, why am I even talking about this? Why does this interest you guys at all? And obviously I'm gonna go with the big hammer of, yeah, because of compliance. Or because of compliance reasons that may come up in the future, right? So we have a customer that wants to create a highly secure in-house cloud system. So, you know, if you're like, not like a bank or whatnot, the things I'm going to talk about, you might not have to implement them at all, right? But if you're like looking into the future and you really need to build high secure systems, this may interest you. And I brought some quotes. Yeah, they want to be BSI compliant. BSI stands for, it's like the Germany's Office for Federal Information Security. Yeah, and they have some guidelines on what ciphers to use to encrypt data at rest. This is the guideline. And they have a quote that I brought with me today, and it essentially says something like, the use of volume encryption alone is only recommended if it includes effective cryptographic protections against data manipulation. So just what I told you about, right? AES-GCM, if I have a ciphertext, I flip a bit, and on decryption, the algorithm will notice that. So that's essentially what this quote means. And you know, another small quote, it is generally recommended to provide mechanisms for data authentication in the overall system. So data authentication you can establish, for example, with an HMAC mechanism, and that authenticates the data, but it also establishes cryptographic integrity of data. Yeah, and the second kind of law that I brought with me today was the Digital Operations Resilience Act, short DORA. It became effective at the beginning of this year, and it wants to ensure that a very important institution here in Europe can withstand, respond, and recover from cyber attacks or system failures. And obviously, you know, when you see system failures, you're like, yes, Ceph can do that. That's already really good. But obviously, cyber attacks are always a problem because they're always kind of different, right? And there you can read a quote that says, the management body shall put in place policies that aim to ensure the maintenance of high standards of availability, authenticity, integrity, and confidentiality of data. So again, the 2 points, it's not enough to establish the confidentiality of your data, but you're also willing to check, okay, is there a way I can establish the authenticity and cryptographic integrity of my data if I'm working in these kinds of environments, you know, banks, insurances, and whatnot. So hopefully you're with me now and kind of understand why I looked into this, at least for, you know, these high security environments. So how can we actually achieve this? So if you Google for like 3 seconds, you'll find this. Oh yeah, AES-GCM, you can only really encrypt 64 gigabytes of data. Yeah, okay, if I want to encrypt a disk that's terabytes large, that's probably not gonna help you, right? So we have to look somewhere else. Yeah, so what we typically do with it, so if you use something like S3, you maybe heard of AES-GCM in the context of object encryption. You know, if we limit the size of an object to 64 gigabytes, this is actually pretty usable, I would say. But for disk encryption, it won't really help you. Yeah. Yeah, you can also read about it in technical standards of BSI, why it is not a good idea, or like what the problems with it are. So what are alternatives? So you could go ahead and use some sort of compound method. So you can use something like AES-XTS. That's like the common solution for disk encryption. You know, if you use something, you know, if you want to encrypt your Linux desktop or something, you'll probably use something like this in AES-XTS. And you combine it with something like an HMAC. HMAC is like, again, a typical means to establish cryptographic integrity. So with these two, you have your confidentiality and cryptographic integrity, no problems. Or you use some other sort of AED ciphers. And there essentially you combine this encryption process with the computation of this HMAC. Kind of the verb for computing HMAC is tagging. So just that you know about it for later. Yeah, it's typically faster, but it also has its problems. And the major problem is essentially, with all the methods I just mentioned, is ciphertext expansion. So typically in AES-XTS or like other ciphers where you only establish confidentiality, you know, your input size is your output size. So if I, let's say, encrypt a 4 kilobyte sector, the output will be 4 kilobyte sector just of encrypted data. But if I use some sort of authenticated encryption, then the input will be 4 kilobytes, the output will be 4 kilobytes, plus some authentication tag. And the entire problem is essentially, how do I deal with this extra bit of data? You know, in S3 encryption, what is done is, you know, you encrypt the object and you just put this authentication tag in the object metadata, and that's it. But how would you do this in a disk encryption context, right? Yeah, so how could you add this into Ceph-CSI? Just for a quick recap. So Kubernetes, or like, yeah, to start from the bottom. So Kubernetes is a way you can deploy, scale, and manage containerized application. Then there's Ceph Rook. Rook is essentially answers the question of how can I deploy and scale a Ceph cluster inside a Kubernetes cluster. And lastly, the Ceph container storage interface. How do I actually make Ceph storage usable inside, like for Kubernetes resources? Yeah, and And Ceph-CSI is specifically about the consumption of like block and multiple volumes. We're not talking about like objects, right? Like if we want to consume objects in Kubernetes, we're talking about cozy. That's a different standard. Okay, so how does encryption work in Ceph-CSI right now? So you might have used the, in the YAML file when you talk about your storage class definition. There's like a flag that says encrypted. It can either be true or false. And if you set it to true, if you set it to false, you will have something like this. You know, the pod writes into your volume, and the volume is mounted with the kernel RBD driver, and writes the data to Ceph or reads the data to Ceph. So pretty simple. You can also do this in a NBD mode if you want to, but you just, for simplicity's sake, I used the KRBD module here. Okay, so with encryption it works a little bit different. You essentially leverage a kernel module, which is called decrypt. And decrypt essentially handles all of your cryptographic operations. So the encrypt decrypt is implemented here in the kernel. So in our Ceph-CSI module, we just deal with I/O essentially, and the kernel takes care of the rest. And you can do this with decrypt for the block storage, for RBD images, or you can do it also with AfroScript. That's also a kernel module for file system. And now, again, like a little explanation of why integrity is important. So let's imagine the Ceph cluster is managed by a third party you don't necessarily trust. So what happens if you use something like AES-GCM, which is the default encryption cipher that's used in Ceph-CSI right now? Then essentially, if somebody flips, let's say, a bit in the Ceph cluster, you read it, decrypt will not say anything. It would just, it gets data, decrypts data, sends it back to the pod. And the cool thing about AES-GCM, if it receives modified data, it will typically return garbage. So random pattern of 0 and 1s, right? And obviously the application, the pod, the application that's running on the pod might go down immediately, right? But it might also continue. If it doesn't expect a format, it can just continue. And and essentially if we were to add some sort of measure that would say, no, we have modified data, we stop now, then that's the difference between noticing, let's say, a cipher, like a cyber attack in like 1 minute, or like half an hour, 6 hours, 10 hours, and whatnot. Like I read a paper from NIST, and alone this capability makes them say, oh yeah, for high secure systems, some sort of cryptographic integrity measure seems to be, is probably a good idea. So what I propose doing is essentially there's already a kernel module which channels this. It's called DM Integrity. It's been in the Linux kernel for around, I would say, 5 to 6 years, so pretty new. And it essentially deals with the ciphertext expansion I was just talking about, right? So you use some type of mode. where the Cipher text expansion is happening, and DM Integrity kind of manages on where to store the Cipher text and where to store the authentication tags. But obviously it comes with like big caveats and problems. So DM Integrity essentially implements some sort of this disk layout, where essentially you have some data chunks that consist of multiple sectors. And then at some point you have a chunk where you store your authentication tags. So, if you see this, you can already think of several problems. What happens if the, metadata segment is not consistent with the data segment? Yeah, that's a pretty huge problem. So they implement a journal, and journaling means obviously performance loss. So that's a big problem. Then no thin provisioning is possible if you use this. And yeah, but let's just say for the problems that I just mentioned, this is like the way of least resistance because it's already existing functionality, and I at the very least want to implement this and then see, okay, how does this actually work? And most important of all, does this actually fit the requirements of our customer? And obviously at the end, BSI. Okay, so how we will use this probably is using this with AES-XTS, so the standard cipher that everyone uses with an HMAC. That should be pretty fast, or like, this will be slow obviously because of the journaling, but it should be okay. And the cool thing here is if there's any error later, let's say in the HMAC computation or when the HMACs are being written at the end, we can just say, oh yeah, please ignore the integrity checks in case of an error, right? Because at the end of the day, we still have AES-XTS encrypted data, and we can just decrypt that in case there's any outage or error. Okay. And yeah, so to my closing words are kind of, data security is evolving, and we store more data, more sensitive data, and obviously the requirements, they become more stringent, more and more gets added. And I'm not necessarily saying that, what I'm doing or is the way to go for everyone. I'm just saying that, there are new laws coming up, and I would rather proactively develop something, push it into community, and, get some feedback on it to see if we actually need to continue this or say, oh yeah, no, what we have is enough actually. Yeah. And that's it. I would skip the last slide, and yeah, thank you for your attention.
Thank you, David. Are there any questions?
At what layer you protect the user data if any other layer is compromised? What's the actual security here? Because you mentioned that if someone stores the data for you.
The idea is if the Ceph cluster, if data is modified on the Ceph cluster, so essentially if the Ceph cluster is compromised, if the Kubernetes worker node is compromised, yeah, then it doesn't really help.
Okay. So you would keep in Kubernetes the keys to unlock the volumes and so on?
Yeah, exactly. And that's how it's also being done right now, right? If you use the encrypted true option, then the Kubernetes worker nodes handle the cryptographic primitives, and they encrypt, decrypt, and have the keys to do it.
But if you do hyperconversion, this only helps. I mean, I understand the context, but usually you would store Kubernetes and Ceph in the same racks or data center. So if a bit flips, it's because you already are compromised, right?
Yeah, if it's in the same rack and the same service, then yes. But as I said, if you buy Ceph storage from a third-party provider, or maybe it's a different data center where you have problems, or yeah, then it should help.
You were talking about storing additional data, but have you taken a look at the additional computational overhead that is happening? I know there are AES instructions, but there's still obviously context switch added.
Yeah, so performance-wise, I have yet to really evaluate it. Actually, I think that the cryptographic operations won't really be the problem, the journaling will be. So from the benchmarks, I saw that that just use DM integrity with the encrypt. That was definitely the case. Yeah.
All right. Is there any other question in the room? Not so. Then, big hand for David Mohren.
Thank you.
Thank you very much.